Assalamu alaikum everyone. Welcome back to Easy Taleem. Today is quite a special lecture because for the first time in this course we are entering what many students think is a completely new chapter, which is series. So here's the interesting thing. It isn't. If you have genuinely understood functions, if you have genuinely understood straight lines, then you have actually already learned the foundation of today's lecture. You just didn't know it. Today I'm going to show you why an arithmetic progression, or as we will call it AP, is nothing more than a straight line, except that we are only interested in integer values. So if this is a straight line, we are not interested in actually integer values, rather in the values at same intervals. It could also be decimal values as well. Now, and once you understand this connection, you'll never memorize another AP formula again. By the end of today's lecture, you'll understand why the nth formula exists, okay? Where the summation formula, so this is nth formula, term n, where the summation formula comes from, why Gauss became so, Carl Gauss became famous at the age of 8, and you will solve genuine Cambridge questions confidently, okay, by the end of this lecture. Then on Monday we'll finish the chapter with geometric progression on Monday, right? Infinite series and sum to infinity. So sum to infinity and sum of n terms of a geometric progression, and what a geometric progression is. So let's begin. Now let's travel back. Functions taught us input, apply. So there was an input, a rule was applied on it, we called it a machine, or in mathematical notation that's an fx, and it produces an output, right? Suppose I tell you y equals to 3x plus 2. Now let's substitute. If x is equal to 1, y equals to 5. If x is equal to 2, y equals to 8. If x is equal to 3, y equals to 11. If x is equal to 4, y is equal to 14, right? Now notice something. We have 5, 8, 11, 14. 5, 8, 11, 14. Now every answer increases by exactly 3 because we are changing the input by exactly 1 unit, right? So there is a difference of plus 3 between all the numbers, and this is constant, right? Now, does this sequence look familiar? Congratulations, you have just created an arithmetic progression. So arithmetic progression is nothing but this sequence, arithmetic progression. So do you see how this is derived from the equation of a straight line? And the formula for an AP is also going to look very similar, which is going to be a plus n minus 1 times d, where this n minus 1 is going to be the nth input, d is going to be the difference between them, and a is going to be the starting value, okay? And we are going to do in a lot more detail. Now, without even opening today's chapter, this is why mathematics is beautiful. Cambridge isn't teaching random topics. Every chapter is secretly connected with the one that you have done earlier. Now, so if I can just, rewrite our input and output again. So instead of x, let me call it n. So 1, 2, 3, 4, it gave me 5, 8, 11, and 14, right? Now, what does the graph of y equals to 3x plus 2 look like? So 3x plus 2 looks, okay, so I will need a bigger space. So 3x plus 2, wait a second, let me use the right tools for it. So 3x plus 2 looks like this. So it has an intercept at 2, and it has a gradient of 3. So after every unit, it increases by 3 units. So 1. So let me extend it further. Let me extend this further as well. So let's say that this is 8. So under it is 2. So after every unit, it changes by 3 units, right? Vertically. Now, so it's a straight line, but today instead of allowing x to take every possible real value, so instead of allowing our input to take every value here, we are only interested in the integer values, okay? So 1, 2, 3, 4, 5. These isolated points from what is called these isolated points, they form what is called an arithmetic sequence, or an arithmetic progression is simply a discrete straight line. I genuinely believe this is the simplest way to understand the chapter. So this is the first point, this is the second point, this is the third point, and all these points lie on the same straight line, but they appear at equal intervals, which is the common difference, as we will explore in a bit. Now, what is an AP? By definition, it's a sequence where consecutive term. Okay, let me write it down. AP, arithmetic progression. It's a sequence. You guys can note it down as well, where consecutive terms differ by a constant amount. Differ by a constant amount, and we will denote this by small d. For example, 3, 7, 11, 15, 19, they differ, all of them differ by 4, right? Now, so it's difference, and they're always constant. Another example is 12, 9, 6, 3, 0, -3. What's the difference here? It is -3, -3, -3, -3. Right? Still, this is an arithmetic progression because no matter the sign of the difference, it is constant. Now, let's say if another sequence is 5, 5, 5, 5, what's the common difference? It's 0, right? So the difference is 0. It still is an arithmetic progression. Now, important point is that the common difference can be positive, negative, or 0. Now, let's introduce a notation. So, an nth term can be expressed by a plus n minus 1 times d. Now, how do I do it? So, let's say, so first of all, write it down, and I will prove it in a bit. So, a is the first term, n is the nth term in the sequence that is desired, and d is the common difference. So it's not the nth term, it's the nth index for the desired output. And t sub n is the nth term. Now, let's say if I write down a sequence, I also want to introduce another term here, which is L, which we are going to use later. This is the last term of a sequence. Let's say this sequence is given to you. Okay, so let's discuss this L term in a bit. Now, so first term, now let's see if you're given 3. Okay, so this is lagging. Let me just reset this very quickly. Oh, wait. All right. So if you have 3, 7, 11, 15, 19, 23. Can you see that I can rewrite all of these as, so this can be written as 3, 3 plus 4, 3 plus 8, 3 plus 12, 3 plus 15, 3 plus 16, and 3 plus 20, right? Now, I can also rewrite the second term in all of these as a multiple of 4, right? So this can be written as 3 plus 4 times 2. So this is 3 plus 4 times 1, 3 plus 4 times 3, 3 plus 4 times 4, and 3 plus 4 times 5. So this is just 3. So I can also rewrite it as 4 times 0. Now, can you see that when this was so this is the first term, second, third, fourth, fifth, and sixth term. So when the term was first, this was 0. So I can also rewrite it as 1 minus 1. When the term was 2, this was just 1. So I can rewrite it as 2 minus 1. Similarly, this can be written as 3 minus 1, 4 minus 1, 5 minus 1, and 6 minus 1. So the nth term may be written as 3, or rather here. So it can be written as the first term, which is 3, plus the common difference, which is 4, into n minus 1. Okay. So this 3 is the first term, this is the common difference, and this is n minus 1. So this is true for any sequence that you come across. So this is a pattern that you should have already noticed. You used to do the same pattern recognition in your O levels and GCSE as well. Now the coefficient of D is always 1 less than the term number, right? So if this is term 6, this is 5. If this is term 3, this is 2. Okay. Now this is the coefficient of D. So you didn't have to memorize it, we built it. This formula is simply the straight line equation in disguise. You can see, so this is the output, this is constant, this is m, and this is x. Okay, so y equals to mx plus c. Nothing different. Now so we have already seen this. So part 2 is going to I broke this first lecture in series down into 2 parts. So this is the end of part 1, and part 2 will naturally continue into deriving the sum formula. So what if I asked you to find me, so if this is 3, 5, 7, 9, 11, all the way to 91, and if I ask you to sum them all up very quickly, now of course it's going to take you a while if you guys start and putting all the numbers in your calculator, right? So what's the formula for sum of n terms? You will tell me that, okay, I will need to put all of these manually in a calculator all the way till 91 and then press equal to sign in order to get the value. Now what if I tell you that all you can do is you can simply find which term is this. So if this is 91, so a plus n minus 1, I don't know which term is this. So this is the first term, this is the second term, this is third, I don't know which term is this, right? So I will just take it as n minus 1 times d. I know the common difference is, so d I can rewrite as term n plus 1 minus term n, the difference of the subsequent terms. Okay, so times 2. So what I can do is 91 minus 3, that is 88. 88 divided by 2 plus 1, so that is 45. So this is the 45th term. Now what if I tell you that we need to find the sum of 45 terms here, right? So I can simply do 45 upon 2, 2 times a, which is 2 times 3, plus n minus 1, that is 44, times d, and this is going to give me the sum of all of these. Let's derive how we do it. Okay, and there is another formula for it, which is n upon 2, first term plus the last term. Here we are going to use the notation L, which I said that I'm going to explain to you in a bit. So now that we have derived that term of n term is a plus n minus 1 times d, let's actually use it. Cambridge doesn't usually ask write the nth term. Instead, it asks you to work backwards. So if it gives you that the 8th term, so let me change color. If it gives you that the 8th term of a sequence is 31 and the first term is 3, right? And it explicitly tells you that this is an arithmetic progression. So what do you need to do? So if the first term is 3, you will say that a is equal to 3 and term 8. So term 8 is 31 and term 8 may be written as a plus n minus 1, which is 8 minus 1 times d. You don't know d, but you do know a, which is 3. So 31 is equal to 3 plus 7d. So this is 28 upon 7 is equal to d is equal to 4. So you already know the value of d as well now. So if it asks you to find the general expression for term n, so that's going to be first term plus n minus 1 times d, which is 4, or you can also rewrite it as they do in Edexcel, plus 4n minus 4, which is going to be 4n minus 1 is going to be term n. But usually in CAIE we leave it here. Okay, so every question starts exactly the same way. Convert the English into mathematics, and that's all. Let's say in example 2, the 4th term is given as 7 and the 10th term is given as 16. I want you guys to pause the video and solve it for yourselves. Now, I hope you guys have done it. So 4th term is going to be equal to a plus n minus 1 times d is equal to 7, and this is also a plus n minus 1 times d is equal to 16. Now solve it simultaneously. 7 minus 3d is equal to 16 minus 9d. which is going to be equal to 6d is equal to 9. So d is going to be equal to 3 upon 2. So the common difference is 1.5, and now substituted back here or here, we are just solving these simultaneously. So this is going to be equal to, a is going to become 5. Okay. No, my bad. So a is going to be equal to 7 minus 9 upon 2, which is going to be equal to 5 upon 2. Okay, so that's the answer. Yeah. Now, notice there was no magic. We just solved these equations simultaneously. Now, if you had to find the number of terms, because Cambridge changes the question slightly. Now, what if it tells you that there is a sequence that starts with negative 3, the second term is 1, 5, and goes all the way till 237. So we can see that our first term is negative 3. The common difference, we can see that a minus minus 3 is 4, 5 minus 1 is 4, right? So common difference is 4, right? And the difference is constant. Therefore, we can say that this is an arithmetic progression. So we can use the formulas that are associated with this. And we also know that the last term is 237. Now, we don't know which number of term is this one, right? So let's say that this is term n, which is 237. So a general formula is a plus n minus 1 times d. We know that a is minus 3, n minus 1 we will write as it is, d is 4. So this becomes 240 upon 4 plus 1 is equal to 61 is equal to nth term. So this 237 is term 61. So there are 61 terms in this sequence. This question is almost guaranteed every few years. Now, so far we have been finding one term. But what if Cambridge asks you to add all of them, right? So 2 plus 5 plus 8 plus 11. Now we enter series. So I absolutely love this story of Carl Gauss, which I told you that we are going to cover in this one. Now, so this guy was around 7 years old. His teacher wanted to keep the class busy. So he said that every that they were supposed to add every number from 1 all the way till 100. Now, so most students began writing 1 plus 2 plus 3 plus 4 plus 5 and started adding them, right? But Gauss finished only in seconds. How? Now, I'll show you something. So what he did was 1, 2, 3, 4. So started writing vertically. And he realized something, that if he so let me write down 95, 96, 97, 98, 99 and 100. Now, if I also write it down in reverse, so this is going to be 1, 2, 3, 4, 5, 6 and all the way. This is going to be 97, 98, 99 and 100. So the sum is going to be what? This is going to be 101, 101, 101 and all the way till 101. Now, how many 101s are these? These are 100 101s. So 100 and time 101s, but you can see that these are two series that we are adding together. So the sum will be half of it, right? So this is nothing but 100 upon 2, and 101 is what? This is 1 plus 100, right? So this is what he did. First term plus last term plus first term. So this is A, this is L, and these are the number of terms. So n upon 2 times A plus L is actually the sum of number of terms. Okay, so this is how you can do it. So there were exactly 100 pairs, 99 and 2, 98 and 3, 97 and 4, 4 and 97, 3 and 98, 2 and 99, 1 and 100, right? Therefore, twice of the sum was equal to 100 times the sum of the first and the last term, that was 101, because 100 plus 1, right? So this is how he actually managed to do it in just a few seconds. That's the entire idea behind the Cambridge proof. Now, let's try to do this properly. So the sum was a plus d. This is the second term. The third term is a plus n. So this is a plus n minus 1 into d. 2 minus 1 is just 1, so a plus d. A plus n minus 1, 3 minus 1 times d is 2d, right? So this is how we are getting all of these. Plus a plus 3d all the way till the last term, right? Now, I can also put all of this in reverse. So this is L, this is A, so this is L minus D. I can rewrite it as that because the preceding term of this L is going to be difference minus that, right? This is going to be L minus 2D. This is going to be L minus 3D plus dot dot dot, and the first term is going to be A. So if I add all of them, so this is 2S, this is A plus L, these both. This is going to be A plus L plus D minus D, which is going to be A plus L plus dot dot dot, and all the way till here, which is A plus L. Now, how many A plus L's are there? Right? So there are n number of them, right? So this is 2S is equal to n times A plus L, and then we can divide both the sides by 2 in order to isolate this S, which gives us that S is equal to sum of n terms is equal to n upon 2 times A plus L. That's it. I don't want you to memorize this. I want you to remember the picture of this, right? So sometimes the last term isn't given. What if you're not given the last term, which, so what if you don't have a 237 as we did in this, in the previous example? So the last term is going to be nothing but A plus n minus 1 times D for n number of terms, right? Now you can substitute this here. So here, which is the final proof. So this becomes S of n is equal to n upon 2. A plus L is A plus n minus 1 times D. So A plus A is 2A. So the formula becomes n upon 2 times 2A plus n minus 1 into D. That's it. So now we have two formulas. One is in terms of the last term. The other is in terms of the number of terms, that is n. One when we know the last term, and the one when we don't know the last term. Now, which formula should you use? So if the last term is known, then you use n upon 2 times A plus L. You don't need to get into, but for that you need to know the number of terms as well, right? So and if last term is not known, then you use n upon 2 times 2A plus n minus 1 times D. Don't memorize, both randomly, choose based on the information. And this one for sum is I mean, you can use it all the time, right? Now let's say let's do a worked example. Let's say that the first number or term 1 or A is equal to negative 12. The 17th term is 12, right? Now, and the last term is 44. So 45, let's say 45. Now, what if you're asked to find the sum given that this is an arithmetic progression? All you need to do is you need to find out n first, right? So first of all, if term 17 is 12, so term 17 is what? A plus n minus 1, which is 17 minus 1 times D. We don't know D, but we do know A, which is negative 12, is equal to 12 because term 17th is 12. So 24 upon 16 is equal to D is equal to 3 upon 2. So we know the common difference, which is 3 upon 2. So, and we know A, which is negative 12. So we can find out which number is this 45, right? Now 45 is equal to A plus n minus 1, we don't know n, times D, which is 3 upon 2. So this becomes 57 times 2 over 3, 3 times 19, 19 times 2 is 38, plus 1 is equal to n, which is 39. Now, we can use either of the formulas. Sum of 39 terms is going to be equal to 39 upon 2, A plus L, A was negative 12, L was 45. This is going to give you the same answer as the other formula, which was 39 over 2, 2A, which is negative 24, plus n minus 1, which is 38, times 2 times D, which is 3 upon 2. You can put it in your calculator and you must get exactly the same answers. Now, it need not be an integer because the difference is 3 upon 2, right? So you are adding. So for example, if n number of terms is giving you an integer, when you add another term which is at a difference of 1.5 from the preceding term, of course, the total sum is going to give you a decimal value. Now, let's do another example. Let's say that the 10th term is 14, and let's say that the first term, the sum of first 7 terms is 42. Find the first term and the common difference. We don't know this. We don't know this, right? Now, this is very easy. Let's form two equations with the given information. So this is term n is 14, term 10. So a plus n minus 1, which is 10 minus 1, that is 9 times d. So that is first equation. The second equation is going to become sum of 7. So sum of 7 is going to be 7 upon 2, right? 2a, we don't know a, plus n minus 1. N minus 1 is 6. 7 minus 1 times d, we don't know d. So this is 84. So 7 times 6, so 12. 12 is equal to 2a plus 6d, or we can also rewrite it as 6 is equal to a plus 3d. Now let's compare the a. So this becomes 14 minus 9d from the first equation and is equal to 6 minus 3d from the second equation. So this becomes 6d is equal to 8, or d is going to be equal to 4 upon 3. If d is equal to 4 upon 3, 6, I can substitute this back in the second equation. So this becomes a plus 3 times 4 upon 3. So 6 is equal to a plus 12. So a is equal to negative 6. And that's our answer. A is equal to negative 6. Or is it? No, sorry. So this, oh my God. So this gets cancelled. So this is 4. So a is equal to 2. Right, and that's the answer. This is one of Cambridge's favorite question styles because it combines both formulas. Now, the common mistakes that are observed here, because I've seen a lot of examiner reports and whatnot. Now, students use n instead of n minus 1. So this is wrong, this is correct. For the nth term, they mix up term number and number of terms. So term n is not equal to n. Okay, n is not equal to n minus 1. So this is the first mistake. This is the second mistake. And Cambridge loves to test you on these traps. They use the wrong sum formula. So sum of n terms for arithmetic progression for an AP is not equal to sum of n terms for a GP. So, and they make these mistakes because they are unable to identify whether the given sequence is an arithmetic progression or a geometric progression. But once we have covered geometric progression on Monday, I will be able to show you how to do how to be able to identify. Students also forget to find n before finding the sum. So if you are finding out sum of terms where the first term is given, the last term is given, but the formula also includes n upon 2. So before you do this, you need to find out n. Students take L as n, which is absolutely wrong. You need to put n. So before that, you need to find out which number of term is this L term, which n is this L term on. They also treat the last term as the number of terms, right, which I was saying. So if you avoid just these 5 mistakes, you have already separated yourself from a large number of candidates. So today, so this lecture is not very lengthy. This is just half an hour long. We have finished the entire arithmetic progression part of the series chapter. So this is the entire arithmetic progression. There is nothing more to it. We now understand what an AP really is, why it is discrete version of a straight line, right? Where the nth term formula comes from. We saw that a plus d, a plus 0, or a plus rather d times 0, then a plus d times 1. You can go back in the video and watch how we did it here, or let me just take you to that screen so that you guys can recall. We derived it here. I used different color for different columns. This one, right? This is how we derived a plus n minus 1 times d, right? We also saw how we can find unknown terms, right? We also saw how to find the number of terms in a given sequence, because so it could be an infinite sequence, right? And it so usually in arithmetic progression you are not given an infinite sequence, right? Now we also saw how Carl Gauss derived the summation idea, how he wrote the sequent terms in reverse and add them up and then divide the sum by 2, and also why both summation formulas work instead of simply memorizing them. So on Monday we'll complete the chapter with geometric progression, right? And we'll cover common ratio, which is r. We'll also cover the nth term of a geometric progression. We are also going to find out the number of terms, the sum of nth terms. We are also going to find out sum of infinite terms. We are also going to do the convergence as well. That how, so let me just, so if I halve this square and if I further halve this square and if I halve this one and if I halve this one, so can you see that this is going to, the sum is going to converge to the area of this entire square, right? So that's going to be equal to the sum of infinity. And the hardest Cambridge past paper questions from this topic we are going to cover. And after that, only in our P1 syllabus, only calculus is going to remain. After Monday, we are only going to be left with differentiation and integration, right? And as per our plan, from the first day, we should be able to complete this entire lecture series on P1 by the 24th of July. So hopefully we are on the track. Now, if this lecture helped you understand the topic instead of just memorizing formulas, subscribe to the channel, share it with someone preparing for 9709 P1. If you found something if you did not find something, if you found something tricky, leave that in the comment and I will make another video on that. Plus, and if you're looking for a structured preparation for the October-November 26 or May-June 27 session, you can reach out to me on my WhatsApp, which is +92 329 329 3028 485. And for a lot of other reference material, you can follow us on our Instagram, where we go by the name of Easy Taleem, EASYTALEEM, right? Join our Easy Taleem classes, and I'll see you guys in the next lecture.